Okay, it's 1 o'clock, it's 11 seconds later. Welcome to our HDF clinic. I think it's number 29, not quite 30, but next week will be 30. No, it is 30. I apologize. It is 30. Welcome. Before we jump into it, are there any questions? So I'm going to pause here. I'm going to pause many more times. But if someone has any questions attending here today, please speak up. There weren't any questions in the Google Doc here, so, but that doesn't mean that there aren't any other questions out there. No? Okay, then we'll just go through our usual motions. Questions, there was one leftover question that I just keep bringing along. Will the HDF 5 112.1 file locking changes be brought to 110.8? And I know Elena is here today. She can either answer now or answer next week.
No, there were no plans to bring those file locking changes in 110.8. I'm sorry, I was thinking about 1.8. Frankly speaking, I need to look into it. So yes, I will prepare the answer for the next session. Okay, great. Yeah, because I know I threw the question here last time shortly after the 112.1 release, and I think someone asked the question, and then I sort of kept postponing it. And okay, you will answer it. That's great. Mm-hmm. Okay. Last week's highlights. In terms of announcements, I didn't see any announcements. The only thing I want to mention is that, hey, it's not too long to our HUG event in the fall in October, and the submission is still open. If you want to give a presentation on something, go to this website here. I'll include that after the meeting in the notes, and yeah, submit your abstract, and somebody will get back in touch with you. And it's going to be a great event. It's going to be on those days, and I think we settled on, was it 9 to 1 or 9:30 to 1 Central Daylight Savings Time, so that it's not too early for folks on the West Coast. Yeah. Mm-hmm. 9 to 1:30 Central Time. 9 to 1:30 Central Time. Okay, so that's not too, maybe not too early for folks on the West Coast, and then, but maybe even some people in Europe who would like to attend. It's not too late for them either. Okay, moving on. There was interesting activity on the forum. I picked one thing, but before I sort of dive into that, I'm going to pause once more and ask anybody who's attending here today, any questions about HDF5 in your application, how to use a feature, how to use a tool. Please speak up. No? Okay, then we'll jump right in. There was an interesting post. Someone was trying to use a custom, a user-defined filter, and they were sort of surprised by, when you have that filter, there are several, we'll see an example in a moment, there are several callbacks that you can implement. The most important one is, of course, the filter function itself that either compresses or decompresses a chunk. And the person was surprised by how many times that function was invoked. So the poster compressed basically one chunk in this case, and was surprised to see that that filter function was actually called twice. And truth be told, I cannot tell you why it's being called twice either. The problem is that, yeah, if you, I think the poster provided a fairly detailed account in the sense of, we saw the H5 dump output and then sort of a snippet of code that looked all in order.
but that person didn't give us sort of what I would call a minimum working example that we can compile and run and sort of verify what's going on. So I would encourage everybody here, if you are posting in the forum, you are really maximizing your chances of success, somebody responding to your post, if you give them a minimum working example that they compile and reproduce and then work off, rather than either not providing an example, providing a rather vague or misleading or otherwise not too helpful to you as the person asking the question. And yeah, a minimum working example goes a long way. And so maybe I will combine that with today's tips and tricks, where we will talk about using a custom filter. What does that mean? And see a minimum working example and talking about, well, how often and under what circumstances does that filtering function get invoked? Okay, using a custom filter. The good news is it's actually not super complicated. What you have to do basically is you have to define a new filter class, and anything related to filtering and compression is a special example of filtering. Requires one of these H5Z _ class _ T structs that you have to define. And then to populate that, you have to talk about, since there are different versions of that struct, you typically want to go with the latest version, but there are some older versions too. Then your filter has to have an identifier. And that's a whole separate topic. Of course, it's total anarchy if everybody would just pick their own filter. And in the documentation, we mentioned that there are certain ranges for these filter IDs defined, where there is a range that's sort of reserved for the use by the HDF group, and then there is a range that is kind of open field day for everybody. But still, if this is a filter that you want to use in production, that you want to share HDF5 files that use that filter that you want to share with others, we encourage you to register that ID with us. So we will issue an ID, and then you can use that ID. And if someone doesn't know that you are the author of that filter, but sees that filter ID, they can go to that web page, that registration page with the HDF group, look up that ID and find information about what kind of filter that is, where the source code is located, and then yeah, just be able to read your data or create new data sets with that filter. Then not all filters implement both decoding and encoding functionality, so you need to indicate that in the structure. And the filter will typically have a human readable name. Some filters have named like deflate or szip or something like that. So here in my little skeleton, I'm basically using a filter function that doesn't do anything, that I just call the identity filter. And I'm using here an identifier that is actually reserved for testing. So if you just do testing or you're just exploring this API, it's perfectly fine. You don't have to tell anybody at the HDF group that you are doing that experiment. Just use that test ID. And then there are basically 3 callbacks. For our purposes here, the only callback that's really relevant is the filter callback, the thing that, again, in the case of compression, would decompress or compress a chunk. But then there are 2 other callbacks that, for example, can look at when you would like to apply this filter to a data set of a certain data type and so forth. There is a callback that can sort of check whether that element type is really compatible, whether your filter can be applied with that. And so you have sort of call them housekeeping functions or management functions, but again, the core functionality is here. But before I sort of go deeper into this program, let's take a step back. Let's look at this filter function here. So again, this is just a callback. This is just a function pointer type, and I'm initializing that to the address of this function called filter, which is declared up here. And this is the prototype for this function. It returns a size t, which is basically the number of valid bytes in a buffer that is available for decompression, for filtering, for decoding or encoding purposes. There is a certain flag argument, then certain parameters, some filters like the deflate filter, for example, you can set a compression level. In the case of szip, there are certain mask arguments that you can set. So many filters will typically have one or more or zero or more arguments, and the number of parameters or configuration parameters maybe that is this cd underscore elements, and then there is an array of length cd underscore elements of at least cd underscore element and elements where you can place these configuration parameters. And then, you provide a buffer of at least n bytes length, and then place the decoded or encoded data into this buffer referred to by a pointer to a pointer buff. And that's it. And inside of this filter function, there are basically two cases. So this filter function, there's only one filter function, and inside of this filter function, you have to basically ask, well, is the HDF5 library calling this filter, calling me, because it wants to decode or encode data, or in the case of a compression filter, if the library wants to decompress data or compress data. And in this case here, since this is the identity filter, I'm not even touching the data. I'm just printing a sort of a diagnostic messages where I say, if the library asks me to decompress something, well, I'm going to pretend that I'm sort of busy at work here decompressing data, or in the converse, if this flag is not specified, then my assumption is that I'm supposed to compress something, and I'm just printing an error message, and that's it. And since I'm not doing anything to the bytes, I just echo that number or return that number of valid bytes, and that's it. So this filter is really probably the most basic filter that you can write. And now let's put this filter to use. So again, the first thing is to declare, to define a structure, to define and initialize a structure for this, as I call it, identity filter, and then register that filter with the HDF5 library. So there's this call h5z register, and then you pass a pointer to the structure, and that should return 0 if successful. And then we can go ahead to create an HDF5 file. There's nothing special about this file, so I'm just using truncate mode in case it exists, and then the default file access and file creation property lists. And then what I'm going to do is I'm going to create a data set that will contain 2 chunks. The reason I'm creating a data set in a moment with 2 chunks will be to not be confused, maybe, that if I'm writing only a single chunk, then having difficulty to attribute the calls to that filter function to writing data. If I'm writing only 1 chunk, I still don't know, well, what would happen if I wrote 2 or more chunks. So that's the simple reason. So I'm using 2048 elements for this data set. But as we will see in a moment, my chunk size is actually 1024, so I'm writing 2 chunks. And then, of course, since we want that data set to be chunked and a filter applied to that data set, we need to create a data set creation property list. So here I'm constructing this thing called DCPL, data set creation property list, with H5P create. And yeah, it's of class H5P underscore data set create. And then we can go ahead and apply or initialize certain properties on this property list. And here are 2 things that I commented out that are just for experimentation. So once we have that going, we want to see, well, if I allocate these chunks early, does that mean my filter gets invoked more often? Or if I set the fill time to never, how does that affect the calling count, so to speak, for that filtering function? But that's commented out. So by default, I'm just using the default properties. So I'm telling the HDF5 library that I would like to apply this identity filter to this data set. So I sort of bake it, if you wish, into the data set creation property list. And all you have to do is provide the ID of that filter. I registered ID 256, but it's that ID field of that class struct. And then I'm telling the library also that the application of that filter is mandatory. It's not optional. So the library, I do not want the library to say, hey, it's optional and I didn't find it and there's nothing to see here. So I really want to force that the library actually calls this filter both on encoding and decoding. And then the last 2 arguments are, the first is the, as we said earlier here, some filters will have configuration parameters. So you will have to provide the length of that configuration parameter array and a pointer for that configuration array itself. But in this case, I don't have any parameters. So I'm going to set this to 0. And for this array pointer, it's just going to be null, and that's going to be fine. And then I just go ahead and pick a chunk size. So we are dealing with a 1-dimensional data set here, as I said, 2048 elements, but I want to write 2 chunks. So I'm going to make that chunk size 1024 elements. Okay. And then I can go ahead and create my data set. So here's my file handle. I'm going to call that data set very fitting dset. And I'll just use 32-bit little endian integers and provide my data space handle. In this case, this would be a link access property list. In this case, there's nothing special that I want to do to these links. There's nothing I want to say about character encoding or creating intermediate files. So there's nothing of that nature here. Then the next argument is our dataset creation property list that we initialized here. And then in this case, there is no specific data access property list. So the default will just do as well. And so that creates me my data set. And then just to sort of exercise this mechanics, so up to this point, we really only wired up that filtering and so forth. In the default case, actually, with the default, as far as allocation time and fill time goes, chunk data sets use what we call late allocation, which means that unless data is written to a chunk, the library will actually not allocate any space for that data set. So I could have made that data set humongous. Nothing would really have happened as far as allocation goes as a result of that data set creation. But just to sort of exercise the mechanics and get this going, I'm going to write some data to this data set. and I will just take a, in this case, uninitialized integer array of 2048. That was the size of my data space. And I'm just calling H5D write here to my data set, and my in-memory type is H5D native int. And I'm writing sort of everything in memory as far as the data space in memory goes, and the file space as far as the file goes, the data set goes. There's no data set transfer property here of note, so the default is just fine. And I pass that data array here as an argument. And that's a good H5D write call. It should trigger 2 chunks to be written. And then there's just some housekeeping here to close all these handles. And then finally, just for discipline and good housekeeping, we should unregister our custom filter. And that's it. So what we are going to do now is basically just let's compile and run this program. And I did that over here. Let's see. It's here. Okay. Let me put this. So I'm going to compile. I called this program filter.c. So just if I do a lesson filter.c, that's this program here that I just showed you. So let's compile this, and it compiles. And if I run this program, I should be seeing conceptually, if my explanation makes sense, the filter will get triggered as a result of writing to 2 chunks, and these 2 chunks will be allocated late. So first chunk is being allocated in memory, data is being written to it, it's filtered, or in this case compressed if you want to think about it this way, written to the file, next chunk allocated in memory, compressed in double quotes, written to the file. So I would expect my filter function to be invoked twice, and I would expect to see this message compressing being printed exactly twice. So let's look at that. And here it is. So running with the defaults as far as allocation time and fill time and whatnot goes, this is invoked twice. Now let's make a slight change to that. And let's, for example, change the let's change the allocation time. Let's change the allocation time to early. And what that means is when I tell the dataset creation property list to do early allocation, what it means that at the time when that dataset gets created, I also want to allocate all the chunks in that dataset. So in this case, since I sized it to have 2 chunks, again, 2048 elements, 1024 chunk size, that's 2 chunks. I want to allocate these 2 chunks immediately when this data set is being created here. And what that means is that now you can think about, well, when these 2 chunks get allocated here, they also the filter will need to be applied to these chunks. And so on first thought, you might think, well, just the creation of the data set alone should trigger my filter function to be called twice, and then 2 more times when we do our writing down here. And that's actually sensible to think about it this way. But of course, if you think about it a little more, you know that since when this allocation takes place, the chunk will get initialized with fill values, and of course these 2, call them blank chunks, so to speak, in terms of their byte by byte layout, they are really identical. So as an optimization, so to speak, for the library, there's absolutely no reason to create two blank chunks and during initialization or allocation, write them twice. It's actually sufficient to create one of these blank chunks, and this blank chunk has the filter already applied. Again, if you take a second copy, initialize it with fill values and apply the filter, since it's deterministic, the answer will be exactly the same. So there's no reason for the library to do that twice. And so that's why, as we will see in a moment, in this case, instead of the expected 4, you will only see 3 times that message compressing. Again, the first one from the creation of this blank chunk that then is being written twice because we chose early allocation and our data set contains 2 chunks. So, but we see it really only once being called for the initialization. And then again, the 2 more times for this write call. So if I save this and go back and recompile and run it again, we see it now 3 times. So this is what we would expect. There are other options here. So for example, you can play with the fill time. In this case, if we still use the default late allocation and set the fill time to never, which basically we are saying, well, since we are completely in this write call down here, since we are completely overriding the data, there is no real point in having additional write calls because that would be just overhead. But from the perspective of invoking our filter, this actually has no, in this particular case, no effect. So if I, in a moment, recompile this and rerun this, we will see the same way as we did with all default values, only 2 calls to our filter, because in this case, what counts is really the allocation, but the allocation is late, meaning our chunks will get allocated only once we start writing to them. The fact that we say, well, don't write any fill values, that saves us a write call, but it has nothing to do in this case with the filter being evoked. So if I save this and compile this again and run it, you see now it's called only twice, and so yeah, that has no effect on how many times that filter is invoked. Now, and that's it. So I think we talked about the remainder of this program. So long story short, I think, and there are many more creation properties with which you can play and so forth. Long story short, I'm a little puzzled by what that user is reporting, but again, without a minimum working example or a little more context, it's difficult, I think, for anyone to make sense of this. But sort of what I just showed here is sort of the intuitive model I think that the documentation conveys, and it just makes no sense for me to speculate what else is going on in that user's program. Okay, I think that that was hanging around one topic today, but I think it was worth it, and in the absence of any other questions, and I think time is also up. Next time
there is a question.
Oh, where
I raised my hand. So when you talk about SD and elements, and I'm sorry, I should probably know the answer. It's clear that we have that application has to pass a buffer that fits, that is described as a buffer of unsigned ints, right? So sometimes compression requires much more complex. So what is the best practice to fit compression parameters does author of the filter need to provide kind of encoding function, give recommendations? Because for some filters we went through hoops and loops to pass it.
Yeah, I think unfortunately at the moment, so yeah, as you can see here, the passage of filters is restricted to a certain number of unsigned integers. Now, a certain number of unsigned integers, and of course, it's an array, so they are sorted, so you can rely on that, that these are positional parameters, if you wish, in a sense that the second position always means the second value, and there's no reordering going on and so forth. Now, if you said, hey, I have a parameter for my filtering function that is a floating point number, or I have a parameter that is of some other type. Well, good news and bad news. Maybe the bad news first. The bad news is that, well, yeah, all you can pass is an array of unsigned integers. But of course, you can, at the end of the day, whatever your more complex type, even a structure or something like that, you can take a size of that. And then if you take the size of that and sort of round it to the next, an unsigned integer in this case would be 4 bytes. So just round it to the next 4 bytes and divide it by 4. And that's the number of unsigned integers that you would need to encode that more complex type. And then, of course, yeah, you would have to do a little bit of bit massaging to, when you receive this array, you would basically take out, you would know, you would document, hopefully, at which sort of positions the unsigned integers are stored, that taken together encode the more complex structure that represent your filter configuration, so to speak, and then do some casting, and then that's a little that's error prone, I would admit that, but then on the other hand, it's not rocket science either. So if you're a C programmer, that's not something that is sort of strange or out of order. That's something we have to do sometimes. But yeah, unfortunately, this interface here is not. I mean, you then have the choice. Could you pass here a void star pointer or something? Sure, you could. But how likely is it, on the other hand, that a filter function would have sort of a very esoteric type and so forth that would require an opaque pointer, for example, to provide, to pass that configuration? Maybe not. I mean, an integer, an array of unsigned integer is basically space that is 4-byte aligned that you can work with. And in that space, you can probably express more or less everything.
Yeah, thank you.
Yeah. Okay,
thanks.
Good. And we are out of time. As always, thank you for coming. I hope this was somewhat helpful. And come back next week, and it's going to be even more fun when Elena does it. And then, yeah, I'll be back at some point. And yeah, come back and enjoy the rest of your day. Bye.